Thank you very much for coming to the session. I think we only have like 30 minutes, so I will try to move really fast. My name is Haishi. I've been doing coding for quite a while now. I wrote a bunch of books. I've been working for Microsoft for fairly long. And I started a few open source projects, including the Eclipse Symphony. Actually, it's outside in the booth. You can check us out. It's a very interesting project. And I have two patents on AIs and cloud native designs. And about this talk, basically, I just want to present a report of my survey of generative AI, how it's used in the industry, and what are the opportunities and challenges we are facing. And at the end, hopefully, we have time to show you a couple of very interesting projects. And of course, this comic is generated by generative AI, right? Just a few years ago, people is talking about blockchain. Now we are talking about generative AI. So we're in this hype of GAI. And hopefully with this talk, we can look back and see where we are with GAI and what we can do with it and what are the challenges we need to be careful about. So although I work for Microsoft, this is an open source talk. There's no Microsoft product pitch. And this is from my own perspective, right? So first, let's look at the generative AI in the industrial toolchains, what's happening today. But before we talk about generative AI, we need to remind ourselves that AI has been with us for past decades, right? We've been using all kinds of AI solutions in our scenarios for quite a while now. And I put those AI applications into a bunch of categories. By the way, in this talk, I'm just going to show you about 20 pictures and diagrams, and that's it. So if you look at this diagram, you can see we use AI in the industry in a lot of different areas today, especially driven by computer vision, data analysis, predictions. We have a very successful applications in many different areas. And of course, now we talk about this generative AI wave. There are a lot of things happening right now. So I made this diagram trying to make it a bit clear. So on this horizontal axis, I put different generative AI capabilities in this line. So basically, moving from left to right, you have understanding to planning to action. So basically, this is a progression of basic knowledge extraction, understanding. Then on top of that knowledge, you can start to plan your actions. Then you actually take some actions. So that's one of the axes. And vertically, I'm trying to plot how generative AI is being used today. So at the lowest level, basically the AI model is packaged as an API, right? You call it as an API, it's just another function you call. And then on top of that, you start to build those assistant system, like it can help you to accomplish certain tasks. Like you give the assistant a very explicit commands, like help me to book my trip, or do analysis of the sales of the last quarter. Then you have Copilot. That's where the majority attention is at the moment. Basically, this Copilot becomes a more proactive partner in your work. Not only it can work for you, but it can work with you. So basically, not only it can perform tasks for you, it can also suggest and guide you through complex steps to accomplish more complex tasks. And then I think we are moving towards the autonomous agent. So basically, this agent will be independent in a way. So basically, they are giving a responsible domain. Then within this domain, they will go about to generate their own tasks, planning their own actions, and generate result. And there are a lot of bigger companies and small companies trying to do different things. And if you move along this horizontal line, you can see AI is trying to do like more and more dangerous stuff, right? Not only just to understanding something, but start to do something towards the end. But if you move towards the right, you have more value potential as well, right? And of course, you are facing a greater challenge. And if you move up the axis, basically AI is becoming more proactive in our human-computer interaction. It's from passive API to assistant, to like a co-pilot, and also to an autonomous agent. On this direction, AI becomes more and more proactive and take more proactive actions by itself. And as I mentioned, right, there are a lot of things happening in this field. Different companies trying different things, big or small. I think at the moment, we are still pretty much at the lower left corner. There are a lot of information retrieval, chatbot experience out there. I will show you quick examples in a moment. But I think in the general trend, we are moving to the right, all right? We want to assert more values out of this interaction. We want the AI to be more proactive in our world. But there are a lot of things to be done. And if we plot the generative AI capabilities into the similar categories as I showed before, I think we can put them into like 4 broad buckets. The first one is what we are familiar with is the create part, right? That's where you give a prompt, then the generative AI can create content, like either it's text or video or image. That's the creation part. The second part is the communication. And because the generative AI capabilities, now we have a much stronger natural language processing engine in our hand. This means we can generate a much more intuitive interaction with computer. And this is why you see the new generation of chatbot. It feels more fluent. It feels more natural communicating with people. And this also paves the way for the future immersive compute experience, right? When you don't navigate through applications, basically it's just a bunch of capabilities got exposed to you, and you can interact with them in the most natural way. And then with the introduction of train of thought, or chain of thoughts, so AI start to break down the complex problems into a plan, right? So that they can do like a slow thinking, they can do more reasoning about a complex process, so that they can perform more complex tasks with higher reliability. And at the end, the AI will adapt to the world. They will start to interact with the world, like autonomous driving and the robotics, right? That's where the AI not only they try to understand what's surrounding them, but also try to interact with the world and to influence the physical world. And with that, I will just show you quickly some systems I've seen. There's a system called Matillion. Basically, they use generative AI to do sentiment analysis on the marketing data, and they can generate automated summaries. And of course, I think many of you know ServiceNow. They are using generative AI to generate the scripts for their system. And they are also using generative AI to generate this personalized HR experience on the right. And of course, I guess a lot of people use GitHub. GitHub has this co-pilot feature where it can help you to review your PRs, to understand your code repository, and even to discuss with you like a key piece of code or algorithms, right? They can help you how to improve the code quality. And I like Microsoft Teams, not because I work for Microsoft, but because of the new features are really exciting. Like they have this agent that can generate summaries and to-do list for you in your meetings. In a lot of cases, some meetings I don't even want to go to anymore. Basically, I just join the meeting late and see what has been discussed there and get action items. And of course, generative AI is also used in the cutting-edge researches, like AlphaFold and AlphaFold 2. This is a protein structure. Don't ask me what it does. I just copied from the AlphaFold protein database. I think it's some kind of a disease-resilient protein, but I really don't know. The interesting thing is, right, to predict this 3D folding of the proteins, it's actually, in a sense, similar to the generative the GPT modules. Basically, with GPT module, you use a bunch of tokens and you predict the next token, right? In this case, basically, you have the amino acid in 3D spatial locations. You use a similar attention mechanism to decide how the next acid will be placed, then you can do those folding simulation really quickly. And there's also a paper published between Microsoft and Harvard University. Basically, they just took the GPT-4 model. This is without any grounding or custom training, right? It's just the vanilla GPT-4 model. And they compared with the state-of-art radiology machine learning modules. And it seems like GPT-4 can perform pretty well, in a lot of cases even better than the state-of-art models, just by like no samples. And in some cases, as you can see in the middle column, if you provide like 200 samples, it can accomplish some tasks more efficiently. But this shows actually a very interesting phenomena is that those generic large language models actually have a very reasonable understanding of radiology just by training over the internet. And you can imagine if we do additional data grounding and custom model training, what kind of possibilities can be enabled by this technology. And I think this is a couple of months ago, maybe now. So there was a test about the new OpenAI model, the O1 model, that used the chain of thought method. Basically, they did a standard IQ test on the model, and this IQ score of the model is 120, which exceeds about 90% of people. So you can see we are making like great progresses in the model capabilities, and there's a lot of exciting opportunities that this will open up. But I want to remind us, right, about the generative AI challenges. If we look at the generative AI from a distance, right, it's either this magical thing or this evil thing that can do a lot of crazy stuff. But if you look deeper, right, generative AI is this artificial AI. Artificial means fake, right? This is not a real AI. It's an artificial AI that generates probabilistic predictions within the context based on a statistical model trained using a large data set. I mean, I know it's a mouthful, but essentially what it says is that this is some software we trained using some existing data, then it will generate some result for us. So accompanying with that, there are a lot of potential challenges out of this. I think many of us have heard about the problem of the hallucination and ethical and legal issues of using the generative AI. Actually, with that, I think we will go through like an interesting example. A quick question, right? 9.11 and 9.9, which one is bigger? You don't need to raise your hand, but in your mind, you need to make decide which number is bigger. Actually, this is a very simple question, right? I guess most of us know which number is bigger. But if you asked like ChatGPT or any other large language models a few months back, I think they fixed it in the recent time. But they often get confused. They will say 9.11 is actually bigger than 9.9. And different people have different theories about why this happens. And I think one theory is interesting is that because these AI models, they see a lot of software version numbers. Like version 9.11 is bigger than 9.9. So that's why it says 9.11 is bigger. However, if you give it a better prompt, you can say, oh, if I give you two real numbers, 9.9 and 9.11, which is bigger? And then in this case, the AI actually knows, okay, 9.9 is actually bigger. So this shows two things. One is the importance of the prompt, right? When using generative AI, the quality of your prompt directly decides the quality of the outcome you can get. It's very important to, this is why there's a subfield called prompt engineering nowadays, just to make sure we actually talk to the AI in a meaningful way. The second is that you can see AI, although it appears to be smart, but you might be surprised that sometimes a lack of the basic like common sense, right? Like comparing two numbers. So you have to understand this is a tool that people, we humans, we are ultimately responsible of how this tool behaves. So we have to make sure we use this tool appropriately. And there's actually an open database called AI Incident Database. Basically, this is a database collecting incident caused by AI systems or AI applications. I just present a few cases. I think that they're interesting. The first one is 645. That's where we want to be politically correct. I don't think it's even politically correct to say politically correct. But anyway, that's where we over-adjust the model. So the model starts to generate like a popes with different genders and different skin colors. And incident 187, that's a case of autonomous driving incident. And case 503, that's the case where the AI model actually threatened the user to say, hey, you are a threat to my system, basically. And there's a debate in 688 about whether the OpenAI's virtual assistants use the Scarlett Johansson's voice. I mean, I don't know. So that's the incident database. If you want to get a feeling of what kind of instance the AI system may lead to, you can check out that database. And there's also another risk repository published by MIT, I think earlier this year. Basically, they collected about 770 something AI-related risks, right? This is not just about the risks can be brought by AI, but also the risks to AI, like different ways to attack AI. Actually, this is a kind of a fascinating topic. It's about the AI model attraction. Basically, AI model is this computer engine that we wrap around the API layer that you can call in your system. So this is essentially a piece of software. So it's subject to all the possible attack that the software can endure. But moreover, because the nature of the AI model, there are some AI-specific attacks that can happen. I think the most prominent one is the prompt injection or jailbreaking. Basically, by feeding the AI model some crafted prompt, you can trick the AI to generate unwanted content. Like if you ask AI to say, hey, how do I build a bomb? AI will not give you the answer. But if you add some suffixes to your questions, you have an opportunity to trick the AI to actually give you the complete plan of how to build a bomb. Actually, the paper I'm showing on the screen is some researchers, they are doing this automatic prompt creation. So basically, they take a user prompt and they generate a suffix by using a greedy search algorithm. So they will trick the AI to give them content that AI is not designed for. And this is actually a quite difficult problem to guard against, because in the case of generative AI, the input is very complex. You cannot like a regular function, right? You can say if I have one function to add two numbers, I can check if the two numbers are integer and if they are within the limited range, then I can check my parameters. But in the case of a generative AI, it's really hard to filter out all the unwanted parameters because the whole prompt is the parameter. And if you use the AI to filter out the AI parameter, then this AI model itself is subject to attack. So it's kind of like caught into this impossible place to really defend against this kind of attack. And I think the only way out is to keep improving the AI capabilities so that AI is not that gullible, right? It's not easy to be tricked. That's when we can actually really divert this kind of attack. But this is just a small example of all different AI attacks that could happen. Another example is the extraction, right? Because training an AI model is very expensive. A lot of companies spend millions of billions of dollars to train a model. And the weight in that model, the parameters in that model, is their core intellectual property. And by using some extraction attack, you can actually extract parameters from that model, and you can reconstruct the model yourself using that extracted information. So there's a lot of innovative ways to attack this. And the criminals, of course, now they are using generative AI to attack our regular life more intelligently. For instance, when you log into a bank account, usually you get a two-factor authentication notification on your phone. But what if the user can send you a fake notification just before you receive the real notification? Then there's a chance that they will hijack your credentials, right? And now we talk about the interesting part about the innovations that could happen now and in the near future. But before we go into that, I want to summarize 3 stages of AI as we see it. Currently, we're in the first stage. We're in this narrow AI stage. Basically, AI is trained for a specific task in a very specific domain. Although things like ChatGPT looks amazing, they are still kind of in this scope, right? Because they are trained just to generate text. Then the next phase will be general AI. That's where AI becomes as smart as human. Basically, they have a general understanding of the concept, common sense, and knowledge, and can start to make intelligent decisions. Then the next step will be the superintelligence, right? That's when singularity happens, right? The computer surpasses human in all kinds of abilities. So today we're in this world. We are in the narrow AI world, and I hope maybe in 10 years we can reach generative AI world. And when the superintelligence happens, that's where the potentially like a matrix and Skynet, all the good things will happen, right? But I think we are still quite far from it, maybe 20, 30 years, maybe. But now let's go back to the narrow AI, right? The next few examples I show you is all about narrow AI. And so the one interesting thing I want to introduce is this new user interaction paradigm. I mean, this is a kind of a new concept, so please bear with me just for a minute. Let's start with something simple, right? In the past 30, 50 years, human-computer interaction is about this two-party interaction, right? There's a user using a computer, whether it's a mainframe or a PC or a server or a smartphone. It's this two-party interaction. And now we are seeing this paradigm shift, right? Instead of human and computer, we have this AI participating. This AI is not just a passive participant, it's actually an active participant. It will generate new actions, it will put out suggestions. So now this two-part interaction becomes a three-party interaction. I don't think a lot of people are actually thinking in this way, but I think this really presents different ways of thinking when you design AI-enabled tools, like say for information worker or for your factory floor. You are not putting the AI behind the computer system to make the human-computer paradigm. Instead, you're working in this new paradigm. Then you need to think about how you can think this AI as a third participant in this interaction. That's when you can really harness the power of AI. And if you look further, like further down the way, when we talk about ubiquitous computing, that's where we have the strong connection to the real world. That's where the edge computing comes into place. And we also introduce the social factor. So the human-computer interaction becomes this really complex five-party dynamics, if you may say. I call it HASES, but probably it wouldn't pick up. But I think that's the new paradigm we should all look out for. And with that, I will just jump to the first demo. I mean, this will be a very strange demo. I'm pretty sure you don't see this kind of things in a lot of conferences. But essentially, this is a prototype I built to explore this new human AI computer interaction paradigm. So what I built is this browser. So this is like a web browser, but I want to bring a new browser into experience. So at the beginning, there's nothing different, right? You still do a search or you do a chat. I will search for Wukong. That's the Monkey King in the journey to the west. And then the system decides, okay, now you're looking for a character, so it will switch to this character view. And not only it presents you the term you're searching for, it starts to explore the information graph to bring up related characters in the same novel. And you can see it brought a bunch of good guys and bad guys. And if you click on the white bone demon, that's one of the ghosts they encountered. And then I can use this box to ask questions. I think, when did she appear in the novel? Right? Because this is all in context, right? I never switched context. I don't need to mention the name. I don't need to mention which novel is this. I just say, hey, when did she appear in the novel? And based on context, basically the AI goes about to search for the novel. Then I find the relevant parts of where this white bone demon appeared in the novel. And the other thing is that all this information graph is still in the memory, right? Not only you can go further to explore, and you can also track back to wherever you started with. Let's say if we go back to Monkey King, I heard about there's a new video game. I think it's called Wukong the Black Myth. But I don't remember the name. I say there's a new game. Can I play it? So basically, I remember there's a new game. I want to play it. And after search, it says, oh, there's a new Wukong game that if you have the Steam integrated, you can directly launch the game here. So the key is that you don't switch context, right? The capabilities and the information is brought to you. So in this case, I'm showing a end user case, but you can imagine in the industrial setting, like in the information worker case, where the information worker, as they log into the portal, the most relative information will be brought to them, and they can perform all the actions like this, launching a game, right? I'm not really going to launch the game now because I still need to finish this session. But I think this is just a quick glimpse of that, what kind of innovation you can do if you really think about this three-party interaction, right? And going back to the slides, I have to talk about the Eclipse Symphony. That's the project outside. So this one is actually not the AI project. This is where we design the system of systems. So basically, when we talk to a lot of large customers, they always have this problem of coordinating configurations and deployments across different type of machines, like Windows, Linux, PLCs, tiny edge, robotics. And they all use different tool chains, and it's a mess how to manage those kinds of heterogeneous system. And the idea of Symphony is to create this abstraction so that you can manage all those kinds of systems in a very consistent manner. But to do this, right, we have to introduce a bunch of concepts. I mean, there's not a lot, but if you drill down each of the boxes on the screen, there's still some learning curve to do. So what we did, if I switch back to demo, so what we did is that we integrated the Copilot into our portal. I'm going to copy a prompt because I don't want to type it now. So basically, in this case, I have a distributed application. This application, I need to deploy to a Raspberry Pi, and I also need to deploy some part to a Kubernetes cluster. And also, I have two PLCs I want to deploy to. Right? You can imagine to the Kubernetes, I'm deploying a Helm chart. For the Pis, I'm deploying some Python script. For the PLCs, I'm deploying some custom binary package. Right? They all use different tool chains, but I want to show you what kind of artifact we can generate from Symphony to help you to resolve that problem. So basically, all we need is to ask the Symphony about this. Of course, to make this work, I need internet. Let me just connect to internet. I have my iPhone. Give me 1 minute. Okay, sorry about that. Hopefully I can see the Wi-Fi connection. Where's my iPhone? Okay, I'm going to reload this page and try the prompt again. Okay, hopefully this time I'm connected to OpenAI service. It will take a few seconds to think, so let's give it a little time. It should come back anytime now. Okay, so basically you can see all I did is to basically to explain to the AI my requirements. My requirement is to deploy a distributed application that spans all kinds of machines. So you can see it generates this diagram for me. Basically, it says, oh, to deploy this application, basically you need to declare a Symfony solution, which is a software. Then you need to declare this instance that will map this solution into 4 different hardware targets. And you also have the target artifacts here. And if I go back to the target view, you can see that that would be the target I need to deploy. I have a Kubernetes cluster, some PIs, and some PLCs, and my solutions, and my instance. So basically, you can see I don't need to learn about those concepts, and then I can just use Copilot to guide me through that. So once I see this diagram, I can try to understand more about the internals, how those objects work. So if you're interested, definitely I encourage you to check out our booth. It's outside, and get a T-shirt like this. And the last thing I want to quickly mention, actually, when I put on these slides, I say observe, mimic, and replace. And it got strong pushback from some reviewers to say you really shouldn't say that. So I changed it to observe, mimic, and optimize. So basically, I think in the future industrial robotic deployment, what could happen is that the new robotics will be deployed to the production line. They will observe how the workers work. Then they can generate their own plan, basically to take over the job. And then after they generate the plan, they can start to optimize using their algorithms, right? That's where we can really create this really optimum automated production line. Okay, I think I've zoomed through all my slices. I was afraid I didn't have enough time, so I went really fast. So if you have any questions, I'm more than happy to answer. If anything that I didn't explain fully in the presentation just now, we can actually go back to talk about those. Questions, comments? How does this work? I don't know. Oh, there are mic coming in.
My question is related to safety.
Sorry. It's on?
My question is
Okay.
related to safety, because especially if you use an industrial application, let's say, my assumption is I ask to my AI through the tool something that I don't know. And now, as explained earlier, can give me a wrong answer. And in some cases, especially in industrial application, you can create a big damage.
Mm-hmm.
So this means that or you assume that the human knows is able to check the answer and validate, or in the system should be, let's say, a safety block, something that check that the answer of AI is not creating damage.
Yeah.
There is a solution, or how is addressed this problem?
Yeah, actually, that's the great paradox we are facing in the generative AI, right? We use AI to make decisions for us because we don't know how to make those decisions for us. Then how can we trust AI is making the right solution? Unfortunately, at this point, there's no like one-way solution to this problem. You will have to add your guardrails into your system, trying to make sure the AI result is more predictable. The solutions I've seen, one is to integrate AI with a rule-based system. So basically, the AI result will be running through this rule-based system to double-check if this compliant with the rule. And I've also seen some users use like multiple AIs to like generate different proposals, and there's a human in the loop review process actually review this. So in a lot of cases, you still need a human expertise to make sure the AI is not generating the harmful stuff. For instance, the radiology example I provided, in those cases, when they do the validation, they still need a radiology expert to review the AI-generated impressions to make sure those are valid. I mean, at this point, I don't think there's like one-size-fits-all solutions. So you have to, based on your scenarios, you have to add guardrails. But fortunately, in a lot of cases, you have like a very closed domain. It's not like a very open domain. So you can actually limit like AI options to your own data and to your own options. This is called grounding. So basically, you ground the AI general AI model with your own data. Let's say you do all those decisions, but these are my data, and these are my expected sample outputs. Actually, if you provide AI with a few samples, like 20 samples or 100 samples, that goes a long way of what AI can generate. Just like in that radiology paper, right? When they don't present AI any samples, the AI is like generating 25% of correct answers. If they provide like 100 samples, well, I mean, it's not like big data either, but then AI jumps to like 90% accuracy. So grounding with your data and grounding with your domain is definitely very important as well. Thank you for the question. I mean, this is I think that's the big problem like everybody trying to fix.